Hello everyone. So in the last video I went over the PowerPoint where we talked about the different types of excuse me, the different types of gas laws and their formulas, and you should have walked away with three main formulas, right? The combined gas law, the ideal gas law, and the partial pressures. Law of partial pressures. So partial pressure is just what it sounds like. P1 plus P2 plus 3P3. You can have as many partial pressures adding up to a total pressure. All the units for pressure must match. It doesn't have to be ATM or millimeters of mercury, but they all have to match. So ATM plus ATM plus ATM, that sort of thing. Combined gas law, your units for pressure and volume have to match, and temperature has to be in Kelvin. So whenever you're calculating temperature with any of these gas laws, the temperature has to be in Kelvin. The temperature has to be in Kelvin. And remember, we took the degrees Celsius, added 273 to get degrees Kelvin. Okay, always have your degrees in Kelvin. And your units for ideal gas law, PV equals nRT. If you memorize the units of your constant, liters ATM over moles Kelvin, then you'll know exactly what units you need for that particular equation, because that's what the units of a constant cancel out the other units. Okay, so that's how you know the units for PV equals nRT. Liters ATM moles Kelvin. All right. So now you have these gas laws and you have the units that they need to be in, which is already kind of picky enough, right? But now you have to know when you're given a set of problems on your exam, when do you use which formula? Okay. Even if you don't have to memorize the formulas for my class, if you're in my class, your tests are take home, but it doesn't help you if you don't know when to use which formula, even if you are taking the test home. So I have a decision map for you to kind of help you logic your way through when to use what formula. So when you're reading the problem, ask yourself, does the problem mention partial pressure? It could also mention total pressure, partial or total pressure. If it does mention one of those two things or both, you use your partial pressure equation. If it doesn't mention partial or total pressure, ask yourself, does the problem mention moles or grams? If it mentions moles or grams, then you're going to use your ideal gas law, PV equals nRT. Okay. If it does not mention moles or grams, then you're going to use your combined gas law at the bottom. So we're going to walk through the problems. You're going to logic your way through figuring out what formula to use, and then you're going to try the problem. And so you're going to get practice figuring out when to use what formula and then using those formulas and the correct units for each formula. Okay? So at what temperature does 3.7 moles of P2O3 gas occupy 667.5 liters if the pressure is 115 kilopascals? So the problem mentions moles, so you use your ideal gas law equation. Remember, this equation has picky units. So pause the video, write out your variables, what variables you're solving for. Make sure you convert what you need to convert to get to the units you're supposed to get to. Once you do all that, you should be able to plug and chug. Okay, so pause the video and give it a go. Alright, so you need to convert those kilopascals into ATM. And you're solving for temperature, so temperature is automatically going to come out the way it should come out as long as you convert everything else you're supposed to convert. And here you only had to convert the pressure to ATM. So you're going to convert that pressure to ATM, then you're going to plug it into your equation here. So you have pressure times volume. It gave you the number of moles and your constant, and T is the variable you're looking for. So you should come out with 254 Kelvin. So air is made up of oxygen gas, nitrogen gas, and carbon dioxide. If the total pressure of air is 765 millimeters of mercury, and the pressure of nitrogen is 0.79 atm, and the pressure of carbon dioxide is 0.05 atm, then what is the partial pressure of O2? Well, we automatically know because it says partial pressure, we use partial pressure equation. Remember, the units must match. Okay, the easiest thing to do is convert that 765 millimeters of mercury to ATM. Pause the video, give that a go, and then we'll go over the answer. Alright, so once you convert that total pressure to ATM, then you're going to be solving for the partial pressure of O2. And so once you convert that, put it into your equation, you should come out with 0.17 ATM for your partial pressure. Okay? You're just going to add these two together and subtract that amount from this side. You should get 0.17. Right? How many grams of CO2 gas would occupy 25.7 liters of volume at a temperature of negative 22 degrees Celsius and a pressure of 997 millimeters of mercury? Remember, the problem mentions grams, so you're going to use your ideal gas law, PV equals nRT. What does temperature always have to be in? Kelvin. So you're going to have to use PV equals, you're going to have to convert your temperature to Kelvin. Then you're going to be able to plug and chug. Now you're going to only be able to solve for for moles, right? So then you're going to need to take your moles and convert them to grams using the molar mass of CO2. So pause the video and give that a go. Okay, so you had to convert, oh, you also had to convert that millimeters of mercury to ATM, right? Your volume was already in liters. Your constant's going to remain the same, and then you had to convert that temperature to Kelvin. You should have come out with 1.64 moles of CO2. Then you use the molar mass of CO2 to convert to grams of CO2. And you should come out with 72.2 grams of CO2. Alright, a gas has a volume of 4.54 liters at 1.65 ATM and 70 degrees Celsius. What pressure would the volume of gas be increased to? At what pressure would the volume of gas be increased to at 5.33 liters if the temperature is increased to 103 Celsius? So that's a lot, right? But we're going to logic our way through it. The problem does not mention partial pressure, grams, or moles. So here we're going to use the combined gas law. What does your temperature always have to be in? Kelvin. And so you convert those temperatures to Kelvin. Make sure your units match. You have liters and liters, and you have, once you convert it, you'll have Kelvin and Kelvin, and so your pressure should come out as ATM automatically once you convert those. So pause the video and give that a go. So here you have your Kelvin at the bottom where you've converted by adding 273, and then you're going to be solving for that pressure right here. Okay, so you should come out with 1.52 ATM. And so I suggest that you practice the problems that are on Canvas. This was just kind of, there wasn't a lot of practice problems up here. This was just to get you to practice using that decision map. And so I would suggest doing all the practice problems you can.